Welcome back to the Punny Math Teacher. So today we're going to go over expectations from the beginning and then we'll get into our notes. We're going to do more word problems today. So expectations, please use twice this video's length. Pause the video, go back, go forward, change the playback speed, do everything you need. That way you can understand, have time to fully write, and actually process the information. This is your time to learn. It's not just watching it for the sake of saying, I watched the video. And then remember, I have my website down there as well for more resources or other ways that you can Google search to find more practice or more notes or self-check games, etc. that are online. So those are expectations. Today we're going to be going over practicing writing equations, and then we're going to move into actually solving them. So you know how to solve them, but if you get to larger situations and larger numbers and more steps, it makes more sense to represent a real-world situation as an equation. That way we can solve it systematically and not just have to guess and check like, okay, this makes sense for this step because of this and things like that. So we can use our brains still, but we can use our brains more effectively by writing an equation. And then we have comprehension questions at the end. All right, so that's minimized. I do want to shout out to Math Aids. I'm going to be using their worksheets for today. So if you wanted to Google Math Aids word problem worksheets or equation word problem worksheets, you'll end up with this page. You can click it and then create whatever worksheet you want. So I'm going to be using those worksheets today for the one-step and two-step equations. And today we are writing equations, so make sure that is all headed up on your paper. And I'm using the PDFs because their handwriting is better than mine, and that way it's already written out so we can then reference those later. I will write the pertinent or abbreviate the problem on my worksheet, on my notes, but just so that you also know what problem we're working with. We're going to start with one-step equations. So when it downloaded, it says one word because it's one-step word problem. And we'll start with number one. Why not? So, starting with number one, Mary has 20 books and 44 magazines in her library. She bought several books at a yard sale over the weekend. Excuse me. She now has 60 books in her library. How many books did she buy at the yard sale? So, if we were going to solve this like before in life, we would have said, okay, so she had, this is number one, she started with 44 books, right? Let's go back. No, 20. She started with 20 books and 44 magazines, and then she now has 60 books in her library. And we're assuming she was keeping the 44 magazines, and the question we're wondering is how many books did she add to her library? So she started with 20 books and 44 magazines, but now she has 60 books, and we're assuming still has 44 magazines. And our question is, how many books did she add? So this is me just pulling information from the problem. It could be extraneous or extra information, and then also the question, because we have to make sure we answer the right question. So if she's adding to her library because now she has more books. I know she added because she has more books. She went from 20 to 60. So you might be thinking, okay, in my head, I'm doing 60 minus 20, and we end up with 40 books as the answer. That's one way to do it. This is an expression. 60 minus 20 is just an expression. You could rewrite this as an equation if you said 60 minus 20 equals x, where x equals the number of books she bought. So she bought 40 books, and this is an equation that would go with that. So I can turn the expression into an equation where it equals the variable or the unknown. I don't know how many books she bought, so I'm going to put a variable as a placeholder for that. A different way I could write this would be, well, I know she had 20 to begin with, but then she bought more books, and that is going to get her with the result of 60 books. X is still the number of books that she bought. And X would still equal 40 books. I don't need to put a unit necessarily because the unit's already in my variable, but you could at the end if you wanted. So either 40 books or x equals 40, both work. But these are two different equations, but they actually give you the same variable value. X will equal 40 because x equals 40 makes both of these true. The left side, 20 plus 40, does equal 60. 60 minus 20, the left side does equal the right side of 40. So left-hand side has to equal the right-hand side. All right, I'm going to change color for our next problem. We'll do one more of this one, and then we'll switch to the other worksheet. And we'll just have 3 problems in our notes, but you can always go and find more. MathAids is a random worksheet generator, so you can always refresh and get totally different problems too. Let's do 3. Why not? After eating at the restaurant, Tom, Nancy, and Benny. Okay, so I want to write down Tom, Nancy, Benny. Decided to divide the bill evenly, so they are going to divide evenly. Nancy did not have dessert. So even though Nancy did not have dessert, they're still going to split it 3 ways. If each person paid $20, what was the total bill? So each person paid $20. What was the total bill? So my question is, total bill equals blank. So I know I have Tom, Nancy, and Benny. They're going to divide the bill evenly. So each person means I have 3 groups of 20 because there were 3 people. Each person paid $20. So my total bill would be, what do you think it is? So you could do 20 plus 20 plus 20. If you leave it as this as an expression, but we're going to work with equations. So we're going to make it equal to the unknown. I'll make it a B. Why not? So B will be the total bill amount in dollars. I'll put it in dollars in parentheses. So B would equal 60. So B equals 60. So the total bill was $60. That's a 6, not a B. Okay. That's another equation I could write. Can you think of one? Okay. What if I had 3 groups of 20? That would be the same thing. 3 groups of 20 is just repeated addition, is multiplication. You could also be funky if you wanted and do 20 equals B minus 40. That would work. It's a weird way to write that from our word problem, but they would all work. So there's more than one equation that can represent a situation, but still get the same answer. So think about, you may have a totally different equation from your partner. Totally fine. As long as your process is still there and you still are using the same information to answer the same question. Okay, so let's do a 2-step one. All right, okay, sure. On Monday, 502 students went on a trip to the zoo. All 9 buses were filled and 7 students had to travel in cars. How many students were in each bus? Better than on the bus, in the bus. Okay, on Monday, 502 students, so 502 students went on the trip. So these are students. All 9 buses were filled, so 9 buses were filled. And 7 students in cars. How many students were in each bus? So our question is, how many students in each bus? All right, so we have lots of things to process now. So I have a 502, and I'm going to draw 9 buses. 1, 2, 3, 1, 2, 3, 1, 2, 3. So I have 9 buses, but then I had 7, 1, 2, 3, 4, 5, 6, 7 students left in cars. So this is kind of like a remainder. I can divide, see how many 9 times something goes into the buses, and then I have a remainder of 7. So I want 9 times S, because that's the number of students, why not? 9 times S, and then I'm going to have a remainder of 7, and that has to equal my total number of students, and S is going to be the number of students in each bus. All right, and then I'm gonna let you figure this one out because we haven't taught how to solve equations yet, so you already know how to guess and check, or if you know how to solve an equation, try it now. That's totally fine. Our next lesson will be on how to solve an equation, 1-step and 2-step, and yeah, so I'm going to, another thing with math aids, which is awesome, oh yeah, we were on 2 steps, is if you scroll to the second page, they give you all your answers. So when you solve this, you should end up with 55 students. So S equals 55, or you could write 55 students. They don't show you the steps, but you can check yourself, so that is nice. So 55 students, or S equals 55. And this is practice writing equations, 1-step and 2-step. And there's a bunch more practice and games online as well for you to try. And our comprehension questions. How can you tell if you need to write an equation or an expression in order to answer a question? Can every equation be written as an expression to answer a question? And then create 2 questions. One that's answered more efficiently by using an expression, and one that's more efficient to use an equation. We had examples like that. 1 and 2, I would say, are more simply solved or more efficiently solved using an expression, but then number 3 that we did in our notes is more efficient for an equation. So try them on your own, and thanks for watching and have a great day.